All of you keep heading. So as we know, we are studying now chapter number 4, laws of motion. So in our today's class, we are going to discuss about spring force. So till now, you see that previous classes, last 3-4 days, we are discussing about the pulleys, and as well as pulleys are attached with the strings. Am I right, everybody? So there is a strings which is attached to the pulleys. So as we all knows that if it is the same string, then something is same. Can you tell me what is that? If it is the same string, then something is same. What is that? Love you?
Tension.
What is same?
Tension.
Tension is same. Yes or no? So now, instead of string, actually this is called as a string. So we all knows that when it is a string, so how the forces are acting, and many problems related to the pulleys and all, we all discussed it. So now today's class we are going to see, like a string, we are going to see the string and as well as the spring. So what is the force exerted by the spring and how to calculate it? That is all we'll discuss it. So we all knows that spring looks like a class 10th solenoid we studied. So similar to that, this is what we used to call as spring. Am I right or wrong, everybody? All of you?
Sir.
So this
Yes.
is what we used to call as a spring. So now let me consider this is the original length of the spring. What is the length of the spring? Everyone? L. Okay. Now, so if I apply the force, for example, if I apply the force like this direction, so definitely there is some elongation of string. The string will extend in some distance. Am I right or wrong, everybody? All of you? Yes, please. So if I try to
Yes, sir.
stretch it, the strength of the length of the string will be little bit elongated. So that is what elongation of string we can say. So the change in this length, that is what we used to say delta x. What is the change in length actually? Delta x. That is what elongation. So elongation in spring, we used to consider delta x. So if the displacement or the elongation is in this direction, then keep it in mind, the spring force will act opposite. Always the spring force will act opposite to the direction of elongation or compression. Let us discuss. Now, elongation is in this direction, so that the spring force, FSP, subscript will say, the spring force is acting backward direction. Do you all understand what I'm saying? So if the elongation is like this direction, the spring force will act in this direction. Okay. Now, for example, this side, if I stretch, suppose in this side, the elongation is that is what delta x. Then here, what about the spring force? The spring force will act in opposite direction. So keep in mind, always the spring force will act opposite to the elongation of spring. So now or else, if I go with the compression, for example, this is the original length of the spring. Keep in mind, according to the class 11th, as we consider string before classes, string is a what actually, including the pulley and string, we used to consider as a what? Massless. I remember everybody. And pulley we used to consider as a frictionless also. Yes, Mr. Rudreswa? Yes.
Yes, sir.
So string is also a massless, and as well as same way, the spring is also, according to the 11th class, the spring is also considered as a what? All of you? Spring is also considered as massless. Understand? Now, if suppose I compress, for example, by the time it is called as compression in spring. So if the compression in spring also, definitely the length will decrease or length will increase. Compression means length will decrease. For example, in this side, if I compress, then what about the spring force will acting? Spring force will acting in forward direction. Do you understand what I'm saying, everybody? Yes?
Yes.
If I compress from this side, then the spring force will act opposite to that. This is what, how the spring force and the elongation or compression in the spring. So that is what you have to remember. So the spring is considered as a massless. Then the spring force formula, which is already we know that the spring force formula is equals to, understanding, minus. So minus indicating what actually? Always opposite to the whom? Minus indicating always opposite to the elongation of spring, not string, or compression of spring. So that if the spring is elongating in this direction, the spring force will act opposite to that. If the compression is taking place in this direction, the spring force will act opposite to that. That is the indicating minus signature. And K is called as spring constant. What is to call everybody? K is called as spring constant, and delta X. Delta X is called as, what is delta X? Either elongation or we used to call it as what? It is the compression. So that is what we used to say, change in length of a spring. Elongation or compression, both are what actually? Delta X means change in what? Change in length of a spring, not a string. String means straight line, keep it in mind. And this is the spring. Okay, so pronunciation maybe may not clear, but you have to understand spring not. So in today's class we are discussing spring or stringer. Spring, okay? Not string. Okay, so that is what. So this is what is formula for spring force. So the spring force is equals to minus K into delta X. So that is only called as, actually this is the very popular law which is known as Hooke's law. What is to call everybody? Who is to called as Hooke's law. So Hooke's law, spring force is equals to minus into K into delta X. This K is called as Spring's constant, or we can say even Hooke's constant. Who is to called as Hooke's constant. That is what you have to remember it. Clear everybody? Now for example, so let me take now, all of you observe. So if there is a string which is attached to the one end and another end is attached to the mass. So now all of you observe, if this mass M is pressing the string, compression, so that the displacement from here to here, the string is compressed, that is called delta X. So then what about the spring force? Spring force will act opposite to that. Am I right or wrong, everybody? So spring force is equals to minus K into delta X. Do you all understand it? So actually you can write spring force is equals to K into delta X, but minus indicating what, everybody? Minus indicating always it is acting opposite to the change in length of the spring. Do you understand, everyone? Clear, all of you? Yes?
Yes, sir.
That is. So now, if I consider the string will be considered as a what? Straight line or like a spring it is? String, it is called as string. So according to the class 11th and 12th syllabus, the string is considered as a what actually? Massless. Okay. So massless, if it is a massless and it is a same string. So same string means if I mention here, 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 everywhere something is constant. Can you tell me? If it is a single string, something is constant. What is that? Tension is always constant. Am I right or wrong, everybody? Yes. Same way, if I consider the spring, all of you observe very carefully. If I consider the spring, now, as we know, the spring is also considered as massless. Spring is also considered as massless. Then if I mention the point here, what is the spring force? Same. If I mention here also, spring force is same. If I mention here also, spring force is same. If it is the same spring, at every point, the spring force is same. That is what you should remember. Clear, everybody? Understand? All of you? Yes. So that is what we used to call as spring and as well as string. Of course, spring problems will solve with the help of string only. So that is what I remember. So remember, all of you, in string, tension is remains constant. In spring, what is remains constant? Spring force is remains constant. Ellame purima? Yes, please, Mr. Narayan. That is what. So now let us take, for example, let me consider two boys now. So let me consider this is Mr. Pradosh. He has been attached to one spring. He is tagging. And there is another boy. So let me consider Mr. Rudreshwar. So he is this side and Mr. Pradosh is here. Now Mr. Rudreshwar is pressing, elongating the string in this direction. This is X1. And Mr. Pradosh is stretching, elongating the string in this direction. That is what X2. That is what delta X and delta X1 and delta X2. So let me consider this is 1 and this is 2. Now you tell me, what is the spring force by Pradosh and what is the spring force by Mr. Rudreshwar? Anybody can tell me? So what will come here? Mr. The spring force. The spring force by Pradosh is equals to, anybody? K into, what will happen? x2, and here what will happen?
X2.
Spring force is equals to everybody.
K
Into
K
into
into
X1.
X1.
A into x1. So here only people made, if you solve like this, then there is a mistake in this. So about here, if you observe very carefully, so what it is saying, this diagram, everyone speak about it. What it is saying, if it is a single string, then everywhere, entire thing, what is that? The spring force will be remains constant, or where is that?
Constant.
Constant.
But if you write it here like separately, then how it will be constant? So you are saying that here the spring force is K into x1, here the spring force is K into x2. Then how it will be same? Because if it's the same string, the spring force must be what? Throughout the spring force must be constant. Am I right or wrong? All of you.
Yes.
Yes, sir.
Then, so this is right or wrong? This is completely wrong. So you cannot write like this, the spring force, because forces is same throughout the spring. So any point if you check it, the spring force must be constant. Clear everybody? So then what to do it? So we all knows that this side the displacement is elongation is x1 and this side elongation is x2. So now we all knows that in this side the spring force is acting in this way, and in this side the spring force is acting in this side. Am I right or wrong, everybody? But the spring force is remains constant or not, everybody? That is what. So in these cases we should take net elongation, or we can say, for example, Mr. Pradosh is pressing this side and Mr. Rudresh are also pressing this side. By that time we have to consider what? Net elongation or net compression? All of you, we have to consider as net compression. So both the sides pressure is applied in the same string, then we have to consider net elongation. So what is the net elongation, everybody? x1 plus x2. So this side x1 and this side x2. So that is what net elongation. So that the spring force is equals to K into x1 plus x2. So that is what? Delta x. So at this point, the spring force is what? Spring force is equals to K into x1 plus x2. And here also, what is the spring force? Everybody. Here also spring force is equals to K into x1 plus x2. That is what you have to understand. Clear, everybody? So if the forces are exerting, so here and at this point and at this point, there is no individual spring force. Throughout the spring, there is same spring force across the spring. So if it is two forces are acting, you should take what? Net elongation or net compression, you should take it. Is it clear, everybody? All of you?
Yes, sir.
Yes, sir.
So that is what you have to remember it. So net elongation or net compression, we should take it. Now, so let us solve. Have you all understand this concept? Everybody clear? Any doubt? Anybody can ask me. So now immediately we'll solve one question related to that so that you'll understand. So now, for example, let me consider the string. For example, there is a mass. So one string is attached to the two masses. So now, so let me take this mass this is structured to 1 meter and this side it is also structured 1 meter. For example, then what will happen here? It is a string actually, so that from away from the point tension, and this is also away from the point tension. Both are equal or not equal? Everybody, tension will be in the same string means tension will be same. Am I right or wrong, everybody?
Yes.
Yes or no?
Equal.
Yeah, tension will be equal in the string. So if you consider like a string, now in place of spring, you just imagine like a string, and let us solve this question. So you'll all understand now. So let me take now, there is a spring. There is a spring. So on the two surface, two objects are there. One is object B and another one is object A. Now, the spring constant K is equals to 100 Newton per meter. What is the unit of spring constant or Hooke's constant? Newton per meter. Okay, 100 Newton per meter. Now, this B is pushing the spring like this, and A is also pushing the spring like this. Okay. Now, the question is find spring force if both blocks are displaced. Both blocks are displaced by 1 meter each. Okay, by 1 meter each. First thing, A case, in same direction. So same direction means then what about the spring force? We have to find it. Let it be first A, will finish it, then we'll go to the B part. So tell me, in both are moving in the, see, find the spring force if both blocks are displaced by 1 meter each in the same direction. So same direction means, let us consider now. For example, we all know that translational motion. Do you remember that each part of the body will travel in the same distance? Remember, Rudreshwa? Translational motion. So each part of the
Yes, sir.
body will travel the same distance. So for example, now you consider which side you want to go, same direction. Either will go like this or like this. Let me consider like this direction, as we are familiar. Now I'll consider A body travel 1 meter, then B body is also travel 1 meter. So means in the sense of, what is the finally elongation or compression of string? Each part of the body, same direction, both are traveling in the same direction. So
Zero.
that, is there any elongation? Anybody? Yes,
No,
please.
sir.
A body will come here and B body is coming here. So finally, what is the net elongation? Everybody, if it is the same direction means, net elongation is equals to what?
0.
All of you, net elongation is equals to 0. Do you all understand or not? Please respond, guys. So then,
Yes, sir.
spring force is equals to K into net elongation is 0, delta X, that's all. So the spring force is equals to anything into 0, how much it is? 0. Clear, everyone? So if a body displaces, understanding, any bodies displaces in the same direction, then always the spring force is equals to 0, because no elongation. Each part of the body will travel the equal distance. So that automatically, what is the elongation? 0 elongation. So the net elongation is 0 means, what is the spring force? Spring force will become 0. Clear, everybody? Understand, all of you? Yes? That is the first thing. Now, for example, B case. In opposite direction. Now there is elongation. Can you tell me? So they will move opposite direction. So now what will happen, all of you? If they will move in opposite direction, then it means in a sense of what? So there is a spring. So this body is traveling this side 1 meter and this body is traveling this side 1 meter. So just imagine like a string. Just now I have drawn. So there is a block. This side it is traveling 1 meter. This side also it is, there is another block. This side also it is traveling 1 meter. Now tell me. So imagine like spring, a spring like string, spring like string. Okay. So we all knows that if this side is a M and this side is also 1 meter and 1 meter, then we all knows that tension in the same string means tension is remains same or where is everybody? Remains same or where is?
Same.
Same. So same way, here also spring force is remains same. Here also the spring force is remains same. So let us see by the time how to solve. So we all knows that the spring force is equals to K into delta X. So can you tell me what is the delta X? Just now we have done. What is the delta X? This side 1 meter and this side 1 meter. So 1 plus 1, which is equals to how much totally?
2
2
meters.
meters. That is what it is. So K into 2. That's all it is. So K value we all knows that they have given 100 Newton per meter into this is 2 meter. So meter will get cancelled. What is the spring force, everybody?
200 Newton.
Spring force is equals to 200 Newton. Do you all understand, all of you, how to find it? So that is what. If it is
Yes,
the
sir.
same direction, the spring force is 0. If it is opposite direction, the spring force is 200 Newtons. The force exerted on the string at every point, spring is 200 Newtons. Do you understand? Aswita, clear? Any doubt in this? Ask. Yes, Ishali, Mr. Narayan, Rohit, Sai Karthik.
Yes, sir.
Any doubt? Clear? So this is what about it. So this is what you should understand it. Next. So are you clear, everybody? Solve this question. Anybody having any doubt, you can ask. Clear, Mr. Pradosh?
Yes, sir.
Now. So let us take normally. So we all knows that there is this string actually. So some mass is attached. So some mass is attached to that. So as we all knows that, then the weight of the body is acting what direction? Downward direction. That is what which is called as mg. And there is this tension in the string which is actually acting in the upward direction. Okay. So let me consider now. As we know that a body is in equilibrium in the sense of when we are in starting, if you attach chain, so there is after, if you leave it for 2-3 days, there is a little bit extension of the string. That is what we used to call as like equilibrium position. So like there is a small, minute, invisible displacement in the string, so that the length of the string is little bit stretched. That is a position we used to call as equilibrium. Okay. So in these cases, can you tell me if the body is in equilibrium, then upward and downward, there is no displacement of the body. So T is equals to what? Everybody. T is equals to
mg.
mg. Yes or no? Tension in the string is equals to weight of the body. Mg. That's all. Now instead of string, you just imagine a spring. You just imagine a spring. So there is a spring now. So where I attached a mass m. So now I left it for undisturbed. I left it for undisturbed. Okay. So now definitely there is an elongation of string. That is what the position we used to call as equilibrium. Equilibrium position. So definitely there is a some length will increases as we are continuously hanging the mass. So there is an elongation in the spring. So elongation we used to call as what? Everybody, we used to call as, yes please, delta x. Okay. So elongation is called as delta x. Am I right or wrong, everyone? Yes please.
Yes, sir.
That is what equilibrium. So this is the position we used to call as equilibrium. So when we attach the body, we never see that. After certain time, there is a slight extension of the spring. That is what we used to call as equilibrium position. Okay. So the change in the length of the spring is only we used to say delta x. Now you remember, basically you observe in our daily life. So if there is a spring, and if you stretch it and if you leave it, so that it will be continuously doing oscillation to and from motion. Am I right or wrong, everybody? All of you? Yes or no? Please respond.
Yes.
Yes. So continuously it will be start vibrating. So that is why in class time, suddenly you see, for example, suddenly if I cut this mass, what will happen, Rudreswa? What is your expectation? The spring will keep on oscillating to and from motion. Am I right or wrong?
Yes, sir.
Yes. So basically that is a nature. If you just stretch this mass and if you leave it, automatically the mass will go up and down, up and down, up and down. Am I right or wrong? All of you? Yes.
Sir.
So that is what basically we used to call as oscillation. So assume that no oscillations are existed. Okay. So oscillation not existed. So entire class 11th, you remember that whenever you are solving the spring sums, so there is no oscillations are existed. Okay. So we are assuming as oscillation is not at all existed. Now you tell me, so the weight of the body is acting downward direction. So what is the weight of the body? Which is equals to what? mg. Okay. Then something is upward is acting. If it is a string, tension is acting. If it is a spring, something is acting. What is acting? If it is a spring, what is acting?
Force.
Yes. Spring force is acting, which is acting upward direction. So I will say spring force is equals to weight of the body. Am I right or wrong, everybody? Clear? Then I want to find how much it is elongated. So we all know that spring force is equals to K into delta X, which is equals to mg. Then delta X is equals to how much, Ra? mg by K.
mg.
Clear, everybody? So that is how we will find what is the elongation of the spring. So just imagine, you have to imagine that to solve entire spring forms. So imagine that the spring is like considered as a what? Spring is considered like a string. Okay. So that's all it is. So if it is a string, if it is a spring, we used to consider as a FSP. That is what we used to call as spring force. If it is the string, string, if it is a string, we used to consider as a what? Everyone? It is considered as a tension. That is what, nothing else is there. Okay. So everything is same. So this is what, how to find the delta X. Now, based upon this, shall we solve one question, everybody?
Yes, sir.
Yes. So very important. So we observe very carefully. So there is a pulley. There is a pulley. So now a pulley is attached to the rigid surface. And one side of the pulley, there is a spring. Spring or stringer? Spring. Okay. And there is mass M is attached to that, and spring constant is K. And another side of the pulley, there is a string. See that one side is spring and another side is what? Spring. Clear, everybody? So here M mass and here 2M mass. So now the question is find elongation of spring. That is what they're asking. So let us see how to find. So as we know, if I leave it for undisturbed, definitely there is a something equilibrium position. Means the something the length of the spring will be extending. Am I right or wrong, everybody? All of you?
Yes, sir.
Yes, that is what we have to find it. That is only they're asking how much elongation of spring will take place. So let us imagine the spring is like a string. I will imagine so that the diagram will be modified like this. So which we have done before. So the diagram will be modified like this. M and this side what will happen? Fastly tell me. Fully sums we have solved many. M. Okay. That is what. Now as we know this side mass is more. So acceleration is downward direction, upward direction. Downward direction. Here
Downward
mass is less, so that acceleration is upward direction. So
Upward
it is a same string. Same string means tension is same or where is? Tension is same or where is? Same. So
Same,
here mg
same.
and here what is the weight? Here what is the weight? Fastly
2
2 mg. Okay.
direction.
Then draw the FBDs. FBD means what? Free body diagram for both the bodies. First body M. Upward is tension. Downward is mg. So as it acceleration is upward. So that this is positive and this is negative. So equation fastly. T minus mg is equals to ma. Am I right or wrong? All of you?
Yes.
Net force is equals to m into a. Am I right, everyone? Second body.
Yes, sir.
What is the second body? You should tell me equation fastly for second body. FBD. Upward
2
is
mg,
tension.
2 mg
Down
minus
is
t
2
equal to
mg. And you can say, so now acceleration is downward direction. So this is positive and this is negative. So what will happen? Fastly. 2 mg
2 mg
minus t is equals to 2 ma. Am I right or wrong? All of you? That's all. So
Yes,
then
sir.
add the both the equations. So add the both the equations, tt will get cancelled. 2 mg minus mg, which is equals to what? Mg.
mg.
Mg is equals to 3 ma. So that's all. Now from that, mm will get cancelled. So a is equals to what? Everybody. A is equals to plus 1. A is equals to how much?
G by 3.
A is equals to G by 3. But they're asking us to find what? What is the elongation? Am I right or wrong? Elongation means what we should find, Pradosh? We have to find what?
Delta X.
Delta x. So if you want to find delta x, let us see. We know only acceleration. So can I find this tension? Because both the sides tension is same. Because it is same string. So I consider here spring is like a what? Spring is considered as a all of you string. Okay. So that is what. So now by substitute that value in any one of the equations. So t minus mg is equals to ma. I'll substitute a is equals to g by 3. So t minus mg is equals to m into a value is how much? G by 3. Now this will come this side. T is equals to mg by 3 plus mg. So which is equals to what is the answer? Tension is equals to what? 4 mg by 3. That is what the tension I got it. But we all knows that the spring force we have to find elongation. So spring force is equals to tension. So that I will say FSP is the spring force. Keep it in mind, subscript it is. So FSP is equals to 4 mg by 3. Okay, va? Ellame puriyuma? Now we all knows that the spring force is equals to what is the formula? K into delta x. So K into delta x is equals to 4 mg divided by 3. So we want delta x. How much is it, Monish? 4 mg divided by 3k. So that is what the elongation of the spring. Okay. So delta x is equals to 4 mg by 3k. Do you all understand how to find it? Everybody clear? Yes. What we have to do it? We have to imagine that spring is like a what? Spring is like a string. Okay.
String.
That's how it is. Understand? Everybody clear? All of you?
Yes, sir.
So please make it. Solve this question. Mr. Rudreshwar, understand? Monish, Murali, Narayan, any doubt? In this you can ask.
Yes, sir.
So please solve it. So you have to imagine that what? Spring is considered as a string. That's all. Then same pulley kind of concept. Brothers, everything clear?
Yes, sir.
Okay. Aswita, you? Lakshmi? Anything doubt? Ask me, Aswita. I'll explain you again once again. You have to just imagine spring is like a string and you have to proceed like a police only. So no other difficulty things. Okay. Next, this question completed. Everybody. Yes. Now. So the next question is, all of you observe very carefully. So we all people know spring balance. Ninth class we will use spring balance. What is the use of spring balance? Spring balance we used to measure what? Mass or weight? To measure weight, we will use the spring balance. Do you all remember that? Ninth class we will study difference between mass and weight. Ellame.
Yes, sir.
Mass means matter present in the body. Weight means mass into acceleration due to gravity. Ellame theriyuma? So mass we used to measure with beam balance, and weight we used to measure with the spring balance. Everyone remember? So spring balance will be like this. So there is attachment for that, and there is a spring inside, and there is a hook down. So if you hang the weight, so that the spring will start stretching based upon the weight. So that there is a measurement here like 0 Newton, 10 Newton, 20 Newtons and all. Elame theriyuma, this is called as spring balance. Everyone knows or not? Yes, please. So spring balance used to measure the what? Weight of the object, mass into acceleration due to gravity. Weight we can use to measure. So that is what weight is equals to force. You might be studied. Both units are what? Newtons only. Okay, guys, all of you. Meeting is going to end. Join back and we'll continue. So based upon the spring balance, now we are going to solve one question. That is why I'm saying that. So spring balance, everybody remember or not? Yes.
Yes.
Okay.
Yes, sir.